Children, we are discussing is matter around the sphere. Is matter around the sphere. This lesson we are studying. In this last class, we have studied extensively about solutions and what are the methods of finding mass by mass percentage, mass by volume by volume percentage, solubility, molarity, everything we discussed in the last class in the solutions. Today we are going to discuss about the suspensions. Suspensions. Children, what do you mean by suspensions? Okay, if I give some famous examples of suspensions, you will understand. Sand in water is a suspension. Sand or soil particles distributed in the dissolved in the water is called just example of suspension. What is the suspension? Suspension is a heterogeneous mixture. It's a mixture. Whereas in solutions, do you remember children? I told homogeneous. I told homogeneous. But these are heterogeneous mixture. Okay, it is not homogeneous. It is a heterogeneous mixture. Okay, in which normally in which solute, okay, particles, solute particles do not dissolve. Of course, they do not dissolve here. But whereas here they used to dissolve, suppose solute, salt or sugar, anything. Here they will dissolve. Here solute particles do not dissolve. Okay, only remain suspended. Remains suspended in the medium, remain suspended in the medium, remain suspended in the medium. What is the suspension? Suspension is a heterogeneous mixture, not homogeneous. Homogeneous is equally distributed, heterogeneous is unequally distributed. So some places it will be more, some places concentration is less. Suspensions are heterogeneous and solute particles do not dissolve. Solute particles they do not dissolve and remains suspended in the mixture, remain suspended in the mixture. Such what are the some of the examples and what are the properties of the suspension we discussed. Okay, coming to the properties of the suspension. Properties. Please, children, all of you listen carefully. Please keep copying, children. No one should waste in time. Okay, first one is it is non-homogeneous. It is heterogeneous or non-homogeneous. Is same meaning, children. Non-homogeneous. And solids are with solute particles are suspended in the solution. Solid particles are suspended. Solid particles are suspended in the medium. Solid particles are suspended in the medium. Okay, to the next one. 1 second. Solid particles are suspended in the medium. Next one, children. Solid particles are particles can be seen with naked eye. Particles can be seen with naked eye. The sand particles or chalk particles, mud, water, everything. Here, whereas in solutions we can't see children. Why? Because they are very microscopic. We can't see. But here, the solute particles we can see with naked eye. Children. Okay, they scatter light. They scatter light. They scatter light because the particles are very big. They scatter light, and particles only get suspended. Particles are suspended in the medium, no, children. So, if what happens, children? What happens if you just okay, children? So, particles are normally suspended in the medium. Suspended in the medium. They do not dissolve. They are suspended in the medium. If you just disturb them like this, they all undergo decantation. They all will undergo precipitation. All the particles will undergo precipitation. And remind children, they can be separated. All these particles can be separated by filtration. All these particles can be separated by filtration. Whereas in solution, we can't filter them by separation. But here, by filter paper, if you keep children, if you keep a filter paper and if you put the suspension, all the solute particles will be filtered. Why? Because the particles are bigger in size. Particles are bigger in size. Some of the famous examples I will give children, or please, okay, note down children. Some of the famous examples of the suspensions I will give. Number one, children, muddy water. Muddy water means sand dissolved in water. Some of the famous ones. Milk of magnesia, magnesium hydroxide, which is used as antacid when we get acidity. Milk of magnesia, magnesium particles are suspended in the water. Okay, sand solution is usually not solution. Sand is suspended in water. Floor in water, floor mixture in water, floor in water. Okay, slaked lime. in after whitewashing. Slaked lime form the calcium hydroxide. Slaked lime after whitewashing. Paints. Okay, paints. Okay, children, in which the dyes are suspended in turpentine, children. Dyes are suspended in turpentine. Paints. Paints are suspensions, children. Paints are suspensions. They are the dyes. Colors are suspended in turpentine. Dyes are suspended in turpentine oil.
There is
Okay,
milk
children.
suspension.
No. Milk is equal white. Next, fog. Fog also, children. What is fog? Water suspended in air. What is fog? Water suspended in air. Water is suspended in air. Where is fog? Chalk powder. Chalk powder, children. Chalk powder suspended in water. Chalk powder suspended in water. Dust particles suspended in air. Dust particles suspended in air. Okay, children. So all these are some of the famous examples of suspension theorem. In the exam, they will be asking. There will be various combinations that they'll ask you to identify which is the solution, which is the suspension, which is the colloid. Maximum number of examples have given so that in exam, if they ask children, you'll be in a position to identify which is the suspension. Suspension means the particles are big in size, and you can see them. Dust particles, we can see them. Chalk particles, we can see them. Fog also, water maturing, that's why paints we can't see, but they are big particles. Then slate line we can see. Floor you can see, sand you can see, magnesium hydroxide, mud you can see. They are non-homogeneous, they are just suspended in the medium. Children, they are non-homogeneous, they are just suspended in the medium, and we can see with naked eye, and they can scatter light, and they are just suspended. If you disturb them, they will be suspended, they will be precipitated, and they can be separated by filtration. Solute particles which are there here, all these particles we can separate them by filtration. We can separate them by filtration. These are the examples of suspensions. And what is suspension? I told children, please all of you keep copying, children. No one should waste time. This is about suspensions. Anyone have any doubts in suspensions, children? Please ask me. If you don't have, then I will go to